It is my pleasure to welcome you to our first Asset Integrity Management webinar of 2025. My name is Elsa Tolsma. I'm responsible for Product Knowledge Management inside Cenosco, and I will be hosting this webinar. Today, we are going to discover the power of reliability-centered maintenance. Let me start by introducing our guest. We have invited domain expert Harry van Tuilingen to lead us in this discovery. Harry is an expert in reliability-centered maintenance with a wealth of experience in inspection and maintenance, spanning many years. He refined his expertise at Shell, where he made significant contributions to the field. In his role as senior domain expert at Cenosco, he continues to leverage his in-depth knowledge and practical insights to enhance our own RCM product. Um, so, before we start, let me outline the framework of the webinar. Harry will start with a general discussion on the competitive advantage of RCM through proactive value add. He will then go into more detail on maintenance libraries, and he will explain the need for a tool. Hereafter, he will go into a bit more detail, focusing on our tool, IMS RCM, and he will be covering hierarchy, priorities and failure modes, RCM guided steps, a maintenance library example, and lastly, touch on dashboards, schedules, and dynamic forms. Um, at the end, there will be time to answer questions. We have already received many upfront, but several of these will be covered already during Harry's talk. So keep an eye out for those. And some he will answer at the end. But please feel free to also add additional questions in this chat, and we will try our best to also get to them. But if we don't get to all the questions, um, don't fear, because we will try to answer all of them also in a separate document and share that at a later stage. Then just lastly, I wanted to note that if for any reason you have a bad connection, a refresh of your browser will normally do the trick. So let's get started. Harry, how are you today?
Very good, Elsa. Thank you for having me, and thank you for having such an enthusiastic and interested crowd to actually follow this webinar. Shall I go on?
Yes, please, you
All
have
right.
the stage.
Okay, good. As you already mentioned, here's some overview of the agenda, but let's get rightly started. So the question is, how to move from, say, a reactive cost-focused activity for maintenance more into a proactive value-adding activity, and how to do that. What is actually the problem here? The problem is often if we build a plant, then in first instance, we're just interested to make product. And so we have typically a maintenance and operational department. But these installations can be quite complex. And there's a lot of equipment involved. And this equipment starts to degrade from the start off. And some degradations go typically slowly and maybe linear in time, but some goes non-linear in time, some goes faster, some goes typically in a non-adulated way where dependent on the operational conditions, sometimes the degradation go a bit faster and then we're slower, etc., etc. So now the question is, with all this equipment degrading and all these maintenance requests popping up, how to deal with this? Because after some time we see that the maintenance department can get overworked and typically operations is unhappy. How to deal with that? Yeah, we call this sometimes also the circle of despair. And in this circle of despair, we see that the backlog is growing. We have no time for preventive maintenance. We see we have partial repairs. We get more repair work. We do selective repairs. We get budget cuts, and the morale drops. So how to deal with that and how to step out of this? You can wonder, in this logic, who's active in reliability, who owns reliability, and who's actually managing the reliability. Here's an overview of some maintenance history for 4 years. And we did this analysis and make this more or less Pareto diagram, and there was one piece of equipment that actually had 80 failures over the 4 years. show you this graph because this helps to get a bit of focus. Where should you start? Yeah, you may start, of course, on which equipment do have high priority repairs and multiple repairs over time. And you may realize from this graph you should focus on this end and not on this end. Yeah. So if you focus up on this end, you will start to bring a bit of peace in your operations. You expect that certain breakdowns will not occur anymore, or maybe later, and you start to get a bit of grip and power over your degradations. One of the reasons I show this graph is that what you expect if your program of reliability improvement is effective, that after some time, you may have addressed this peak here, and then you need to address for the next year. So then you can say, hey, after a few years, if you do this mains history analysis again, you expect this to go down, and later on to go this to go down even further. Yeah. And this may help you to focus on the high priorities and the repeat repairs to free up some resources and to improve your reliability. So you may wonder, how does this connect to RCM? In RCM, we are interested, okay, what caused the equipment to fail? What are actually the ways it can fail? We call that failure modes. And when we know these failure modes, what can we do to prevent or predict the degradation and take action and actually get our performance up? A part of that maintenance of that installation is, say, managed under what we call asset management. And in asset management, we can describe a few processes. This can be very detailed, so here I just want to keep it simple. But the main objects of our asset management is that, we want to reduce our business risk. We want to increase our revenues, make more money, but at the same time, we want to reduce our cost. And then we're interested how to balance these three and come to a balanced approach. So in asset management, we typically start off with what we call the executing processes to maintain the plant, which is typically in the area of maintenance execution and turnaround. And there's often a managerial process to overlook that and to have a look at risk and to intervene there. But on the turnaround and maintenance execution process, we also see that SAP is involved to actually hold those objects in, for instance, notifications and work orders. And then we can measure our performance, but if our performance is poor, our manager gets angry. And from the angry manager, we actually end up in what we call analyzing processes. So in the analyzing processes, this can be in a reactive way, something went wrong, what to do with it, and we do an investigation, sometimes called root cause analysis or nowadays causal learning. But it can also be done in a proactive way to take action before the next failures come. And here we see that the processes of reliability-centered maintenance, risk-based inspection, or instrument protective functions come in. Where RCM is related to reliability, risk-based inspection to integrity of mechanical equipment, and instrument protective functions to safeguarding instrument systems. And here we see that the tool that we own, actually the IMS tool, holds this area. So in this picture, this also gives a bit of an idea what is actually taken care of in SAP and what should be taken care of in IMS. If you think of what kind of functions can go wrong, then we have a list here of what are the typical functional aspects of a plant. And one of the things you might want to start with is, okay, what is the production reference plan? What are my targets? Do I meet my targets? And do I measure my performance against the target? One of the first things what you should do is make sure you measure your performance. And from that performance, you should actually see what your gap is. From here, we can check out if you have a license to operate aspects, how to deal with products storage capacity, do we have storage there, how to maintain that, and know the phases in the production process. Why do we do that? Well, we typically follow in RCM the 7 questions of RCM. And these 7 questions of RCM, they seem simple and rigid on one side, but they are actually a very good guide on where we're looking for. So, and often we see in maintenance that we may overlook the first two questions. What are the function and performance standard of the asset or the unit? In what way can it fail to fulfill those functions? And actually, these first two are an indication where are our risks and how to deal with those risks. From there, the RCM questions help us to say what can cause those failures. But one of the most important questions in RCM is question 4. What happens when each failure occurs? And this is actually a question where you are forced to understand how your equipment degrades and how it may fail and what is the failed state. And from there, you can then say, hey, what can we do to keep that into good shape? And if you do those tasks, is there enough risk reduction? Is there economic benefit with the task we have? And if there's not enough risk reduction or economic benefit, what can we do to get an alternative there? If we look at the cost effectiveness of maintenance, we see that if we do more maintenance, then we actually spend more money, and we expect, of course, that the cost of non-availability goes down. Yeah, and then we end up in an area that we call risk-based, where we look for an optimum. If we don't do enough maintenance, we are under-maintained, and if we do too much maintenance, we are over-maintained. But you can wonder, what is a risk-based approach? Well, the point of a risk-based approach is actually that you want to make an estimate of the risk if you do nothing, and the amount of risk if you do nothing is actually a measure of how much resource you have to do something. So if you look at the risk-based, you actually see that we compare two situations. First, we do no maintenance and then check what is the risk level. Then we do the do maintenance activity, and then we're interested, is there any residual risk? So if there's high risk, we do high maintenance. If there's low risk, we do low maintenance. If we look at failure modes, actually a failure mode is a way in which an equipment can fail. And we follow the failure modes according to the definition of Mr. John Mowbray. And John Mowbray, who wrote a very interesting book on RCM, said actually failure mode is a concatenation of two words, an item and a failure description, or a noun and a verb. For example, if you look at bearing failure, is that a good failure mode? Well, it's a good item, the bearing, you can hold it, but failure is a bit vague. Actually, you could say, hey, I would like to look at how can a bearing degrade? And you could ask, what's the function of the bearing? Well, it's to keep the shaft in place, but also allow a low friction rotational movement. So from there, what can go wrong? Well, you can get clearance on your bearing and you don't keep shaft in place. So you get bearing wear. But the bearing wear can be driven if the lubrication is not good enough. So this can be driven by what we call lubrication failure. So if we take an example of a simple centrifugal overhang pump with two bearings here, we can wonder, in this situation, how would bearing failure be driven? Well, this could be by low oil level. And now, if we look at these aspects, bearing wear and low oil level, we can actually wonder, how can we determine that this is occurring? And this comes back to question 4 of RCM. What happens when the failure occurs? So here, how would we determine bearing wear? Well, we got too much clearance and we may get vibration. Low oil level, how can we detect that? Well, we might have a side glass and we can look at it. Yeah. So what I'm trying to do is I'm trying to look at these aspects and how can we connect it to a technical argument. Yeah. But it also can have oil degradation. Well, what is degraded oil? Well, it may not look like apple juice anymore, but something like this. This is typically old oil, not so good. Yeah. Of course, there can also be particles in it or water, but actually it is losing its lubricating. Yeah. Then you can wonder, if I have a piece of equipment, now I'm interested which failure modes can occur here. How to determine the failure modes? Well, if you want to determine the failure modes of a piece of equipment, I would recommend you first take a look at the picture of the equipment. How does it look like? Take a look at a cross-sectional drawing. What is internally there? What are wearable parts? What are parts that can corrode, erode, maybe foul up, etc.? And from there, you can wonder, do I have some maintenance history on this, or do I have a maintenance manual? In the maintenance manual, there's often a list of spare parts that are recommended, and this is then what we call a recommended spare part list. And you can see it coming that a failure mode, which is a part with a failure descriptor, may be listed in the recommended spare part list of the vendor. Yeah. So the recommended spare part list of a vendor can help you to say, hey, what of these spare parts may degrade? What do I expect? What is the consumption? And from there, what may be the failure modes that can occur on my equipment? And based on the buildup and those degradations and failure modes, you can wonder, how would that then lead to a failure of an equipment? Yeah. And there you should look in the P&ID and check out where's the pump in the P&ID. In this situation, you see there's an A and a B pump. And this also helps to say, hey, what are the products that go through that pump? What are the temperatures and maybe the composition of that product? But also what will happen if the equipment fails and which failure modes are more important and less important. And from here, we can make a list of the failure modes. And we may say, hey, let's focus on the dominant failure modes. These are the failure modes that most regularly occur. And what maintenance can we do to avoid those dominant failure modes? If we then go back to this overview of these failure modes, now we may wonder, if we look at this question 4 of RCM, can you describe what happens when the failure occurs? How would this then maybe come together if we look at these 3 aspects? Yeah. So we may draw a line where we see a minimum acceptable condition, we see the performance of the equipment, and we may get low oil level. If we get low oil level, then very quickly the bearings run out and the equipment stops. So if we take care of the oil level, that is already better. If we then do nothing on that oil anymore, then the oil may degrade because of condensation, degradation, or other issues. And that can cause an accelerated degradation of the bearings. So now if you keep them well lubricated and running nicely, then we may get, say, the normal bearing wear that is anticipated in the design. Yeah? This may cause at a certain moment that the vibration gets up. Gradually the bearing loses his low friction ability to keep the shaft in place. We get more noise, the bearing gets hot, starts to absorb more energy, and in the end the electric motor may stop on overpower. Yeah. So why do we put this in a graph? Well, this graph may help us in this question 4 of RCM. In what way may it degrade and how would this tie together? And here you can have a number of points where you can detect what's going wrong. Yeah. Next to this, you can of course then put tasks on these P points. Yeah. So we can say, hey, I need to check the oil level. Here I need to replace the oil. Here I need to regular vibration monitoring. Here I need to do operator check around. Does he hear anything strange? Maybe measure the bearing temperature once a day, and from there I am sure that my pump is in good health. Yeah. So from here we can make an estimate what will be the risk if we do nothing, and this is then built up in a probability and a consequence. And on the consequence side, we can of course look at the asset aspects, the people aspects, and there are environmental aspects. And this gives us then an indication what is the criticality if we do nothing. And as I said, in a risk-based approach, you would say, hey, if we do nothing and we have a certain criticality, if the criticality is higher, we can do more maintenance. But if the criticality is lower, we may have not enough funds to do maintenance. Here's an overview of how can we then take action. Well, we may take our degradation graph and look at the description of how this degrades, and then from there determine the tasks and then make an estimate what will be the risk reduction. Here's an overview of how this then would go. So over the various equipment, we first have a no maintenance scenario. Next, we have the do maintenance scenario. We come forward with the tasks, and from there we decide if this is good enough. You can say, hey, yeah, this is quite some work to do this failure mode by failure mode. Yeah. So you can wonder, should we go through this 7 questions always, and do actually these analysis one by one for all these failure modes? Well, I personally would say it would be good to regularly do an RCM study and keep your RCM knowledge and competence and capability in place. But there might be reasons why an RCM study may not be that effective for you to justify all that work. So here I have a few arguments why an RCM study may not be that effective as you expect. Yeah. For instance, if your maintenance history is not accurate enough, so it may be in a short period of time, it may be maybe not applicable for the unit that you have. Next, you may have a situation where your experience and your knowledge of the plant and the degradation is not strong. Yeah, it could be due to turnover of your crafts and your specialist, or it may be that the unit is just rather new. Or maybe you have a new maintenance contractor in place, who is quite new to this and have no clue on how this worked in the past. Another aspect may be that already sometimes during the RCM studies, people realize that they are not having that detailed analysis information, and they start to generalize already in the RCM study, for instance, by doing a lot of copy paste of the analysis. Yeah. But even if you can use all your information, and if it's very specific and detailed, sometimes the maintenance task that then might be different for the various types of equipment is not appreciated by your maintenance department who need to execute this, because they will say, hey, we don't want all these different intervals for these tasks. Can we please align this, because it makes our execution much more simpler and robust. Yeah. So these can be arguments to say, hey, we can justify a more generalized RCM analysis, but at the same time, you do wise to use the 7 questions of RCM to verify, how good are these templated RCM analysis, because in the end, we're cutting corners, and we are skipping a few of those aspects. So here's an example of what we can do in our tool, for instance, and we call this a maintenance library. And here you see that actually a maintenance library is shown based on some object types. And here you see a number of failure modes that are applied in this maintenance library. Yeah. So after you maybe have decided for which equipment you want to do a detailed RCM study, then you can make a decision, okay, well, for which equipment am I interested for a maintenance library? Can we actually check out if there are common equipment types, and for there, which templates can we create? Yeah, and here, it's a simple example. You could think of centrifugal pumps, other rotary equipment that are similar, heat exchangers, control valves, batteries, low voltage motors, and instruments. Yeah. You do wise to involve your discipline experts to say, hey, we want to standardize this. And maybe your discipline experts already have some templates that they use. You can say, hey, maybe you can use your templates that you use for the maintenance of our equipment, and we can use those templates and put them in a maintenance library and apply that easier to multiple equipment. Yeah. How to create such a maintenance library? Well, if you say, hey, let's create a maintenance library for some valves, here I just put some valves together. You can wonder, can we do this one maintenance library? I think you quickly realize that, hey, this is a ball valve, it's a big actuator, this is solenoid, this is a motor operated valve, this is a TSO valve, this is a Masonilin and a butterfly valve. They are quite different. They don't even look like the same. So my advice is, if you follow these steps here that we promote you to identify the failure modes you already see from the pictures and from the build-up, where you have commonalities and where you can create an RSL for one group of these and where you need to create another one for the others. So always take a look at your own equipment if you create a maintenance library. Yeah. From there, you can use the 7 questions of RCM. And here I have an example for a globe control valve, some of the failure modes where you may want to take action on in a template. Yeah. In the tool we have a number of clients, and these clients are also active in producing maintenance libraries. And here's an example where what we call the global RSLs, the global reliability strategy libraries, the global RSLs are actually listed. You see here in our tool under the maintenance library tab that there are 306 global RSLs. I cannot say they are all perfect and super good, but they might be good enough for you to say, hey, let's have a look. Maybe we can copy it over, split it up, apply it for our own equipment, and make use of that instead of identifying this from the start onwards and do all the work ourselves. This might drive you to the question, do we need a tool? Yeah, we have worked with quite some clients, and some of these clients, and we understand that very well, maybe shy of a bit of an IT tool, and I can understand that. We have a few people who contacted us and say, yeah, we do now RCM in an Excel sheet, but it's not so easy, and can you help us? So here I have an example where you already see, hey, people try to set this up, they think 7 questions of RCM. I made 7 columns and I'm okay, but before this starts to grow, people already realize, hey, it's getting bigger and bigger and bigger, I can say typically after 300 analysis, people say, hey, it's difficult to scale up, it's difficult to maintain, and it's even harder to report on this and to work on this, especially if you work with multiple people in an organization. Yeah, here's another example of such an Excel list, and that's the reason why I think you're either wise to start using a tool. Here you see another screen from the tool. And why do I show you this screen? Well, I want to show you the screen because in this screen you see here there are a number of what we call grids, and in each grid you see a table. And we try to represent the information as illustrative as possible. So there's no direct need for much reporting. You can do a high level of reporting already from the available grids and from the data you already have. All these blue text here are actually object links, and if you click on it, you move to that piece of information. This is all maintained in the browser, so you can right click on it, say open in a new tab. In the new tab, look at the details, go back and make use of all the easy aspects of the browsers that we see today. Also, you see here that there's also connected information, like for instance, how many failure modes are there, how many tasks, what is the criticality, etc. Another picture I like to show you here is from the equipment grid. That's this grid here, and in this case, this client had more than 700,000 equipment. You may realize, if you try to do this in Excel, there's maybe one person already busy and dealing with that Excel list full time. Yeah. So here, I think the data is more easily available upon you and more easily to work and to maintain. One of the things there is that we can create dashboards, and the dashboard can pull the data, of course, out of the tool. And here you see an example of an RCM quality dashboard where you see things say, hey, what's the completeness of the analysis? What are the criticalities, residual risks? Are these analyses actually approved after they are completed? What is the economic class there? And what is the ratio of the risk reduction here in terms of probability? And actually, this helps to say, hey, do we have a clear argument on what the quality is on our RCM study? And if we are in the position to put this in a dashboard, we can use this dashboard in our regular reports and show this dashboard to say, hey, we check out a part in the tool, some data, we see, hey, there are areas with room for improvement, and we can take then an action, a tactic to improve that, and start an RCM analysis on that. Yeah. Some background on the hierarchy. So actually, we use in the tool, as I showed you before, this tool is typically closely connected to SAP. So we take over the asset hierarchy in SAP, and the asset hierarchy in SAP is the master of that. So we can interface this where the data comes over from SAP to IMS, and the core starts is there, company, site, plant, the unit, and under the unit we can create our function locations and equipment. In RCM we can do RCM analysis both on flock level and on equipment level, and we're quite flexible there. And one of the first steps in an RCM study is actually what we call the failure mode and effect analysis. If we get failure modes, what is the effect of that failure mode? And we connect that to the first two questions of RCM. Okay, what's the function of my asset and where can it fail to fulfill those functions? And maybe if the unit is big, it's very hard to identify how can a failure of equipment cause a failure of that unit. So in the tool, we can split off a unit and actually create systems. At least we need to have one system, but it could be that in a unit we have multiple systems where we can also narrow down the functional failures, and that might be closely connected to the production process in that unit. Yeah, so each typical unit operation of that production unit is in a particular system. Yeah, so from the unit, we typically want to define what we call some economic data, and here we have an equation that says, hey, if we have a number of hours downtime, what would that cost? And we call that the product loss equation, and that is to bring in the economics if you look at downtime. So from the system we can have functions, and on the equipment we can have functions, and over time we get degradations, and that can cause that a failure mode occurs, and that failure mode can cause a failure of the equipment. And now the question is, can a failure of the equipment cause a failure of the system, and how much would that cost? So this is the structure that's in the tool. So why is that they're there in this way? Well, by doing it this way, we can actually be responsible to all the 7 questions of RCM and hold it in the tool. And at the same time, have a practical approach. Yeah. Here's an example of a simple hydrogen desulfurization unit. And in this case, we have here a reaction section, here a stripper section, and here a gas recycle section. And what we said earlier, okay, what is the function of the plant, and where can it actually fail to fulfill that function? Of course, our first interest may be, okay, where can we fail to get the desulfurized product out? But also in this diagrams we have intermediate products, sour water. We don't want to have hydrocarbons in the sour water. We get sour gas. We don't want to have too much water vapor in the sour gas. Here we have purge gas, which is clean here. It's amine treated. So this is H2S free gas. Here we got rich amine out, but we don't want to get hydrocarbons there. And here we get hydrogen rich recycled gas, and we want their efficient flow of that hydrogen gas. And all these things that I just mentioned, you can argue there are functional requirements, and that can raise the question, what failure on which equipment can cause functional failures there, and to which extent does it then matter? So here we split it up in 3 systems, and for each system we can define what is the function, and from there what kind of functional failure may occur. In the tool here we have an overview of those systems, and per system we can get a bit of an insight. Okay, how big is the system? How many flock and equipment are there? How many failure modes are there? And what are the criticalities, etc. So if we look at how to do an RCM study, I wanted to actually be very explicit on the steps. So here we see a few of the aspects that need to be defined up front. With typically, of course, site plant unit and the production loss equation, turnaround, and implementation system. This is where the tasks are held for execution. From here, we can say, hey, we create our systems with the function and function failures defined, assign the flux and equipment to the systems, and then to prioritize that, to actually do a bit of a quick and dirty assessment. Okay, what are the more important equipment? What is the medium important equipment? And what is the equipment that we actually not so much bothered with? So here, for the higher priorities, we go through the failure modes, put together the scenarios, criticality, strategies, tasks, and the economics. If this is complete, then we go to the next failure mode for that equipment or the next equipment, or if you had all the equipment in that system, to the next system or next unit, and even maybe to the next plant. So in this approach, we may have done all the RCM analysis for a certain particular plant or unit, and next we might then say, hey, now we want to assign maintenance libraries to that medium critical equipment. So here's some example of how an analysis may look like, just to give you a bit of a flavor. And here we see some equipment type. This is electrical with motors, low voltage motors. So here you see there were 549 low voltage motors analyzed. And here you see there were 21 with one failure mode, 11 with two, and 517 with three failure modes. Or the average is 2.9 failure mode per equipment. And making an overview of this actually helps you to give a bit of insight. How detailed was the analysis done? Was it a very flat approach, or was it relatively deeply analyzed? So we can also do that here for instrumentation. Interestingly, I see here there are 440 globe control valves with 5 failure modes. Pretty deeply analyzed. We can do this also for mechanics, for mechanical. So here we see on the mechanical. But overall, this helps to say, hey, we got 2,600 equipment analyzed, and there are 9,300 failure modes, or an average of 3.5 failure mode per equipment. And by doing this analysis after you did your RCM study, you start to develop a bit of sense of what's quality, what's good, what's not good, what do I learn from it. But next to how deeply is it analyzed, you can actually wonder, what was the risk reduction? So here I put this in an overview, where here on the criticalities, from extreme high, medium low, and negligible, to what is the risk reduction. And here you see there were 2 extreme criticalities reduced to high, and 6 to medium high, 1 to medium. So this gives a bit of an insight, how is the risk reduction done. But this can also help to say, hey, which areas am I interested in to verify? Personally, I'm always very critical on extreme and high criticalities. I want to see what are the scenarios. What are the expectations? On the other side, residual risk of level high or medium high is a bit too high. Did we do all our best to reduce this? Is this credible? Is it realistic? And you can actually say, hey, maybe we need to verify this to check the quality. To set priorities and to identify what are the more critical and less critical equipment, we actually can go through the various steps of the analysis. We need, of course, to know what's the buildup of the equipment. And in the tool, we can then say, hey, is this a higher priority, a medium priority, or low priority? And from the higher priority, we can say, hey, we'll do the RCM study. And if it's medium, we can apply a template. Here, I show you how to add failure modes. In the tool, there's a whole set of failure modes available. And in this case, on the heat exchanger, we can have, say, fouling on the tube side and tube leakage, which are the dominant failure modes of a heat exchanger. From that failure mode, we can go to what we call the guided steps. And in the guided steps, we actually bring together the failure facts, the criticality assessment. We look at the strategy, go to the maintenance task, and here look at the economics. So here you see in the screen the failure facts, and here in the screen the criticality metrics. And actually the guided steps of RCM help you to go through those steps. And each time you have completed the step, you go to the next steps, and you are actually guided in that process. After you complete the RCM analysis, you can get an overview in one screen, or you can go here to the analysis grid, and in the analysis grid, each failure mode is one row, and in that row, you will see what is your scenario, what is your criticality, what are your maintenance tasks, what is your economics, and actually, is the RCM analysis completed, and do you have enough economic justification to do the tasks? How do we deal with the maintenance library in the tool? Well, first let's look at the steps involved. If we start off with the maintenance library, here the starting point is we already did the prioritization. So now we can look at, hey, which Floxen equipment by the object types do we have? Can we make an inventory for which we have enough installed base to make an RSL? And here we can decide, hey, do we need to create an RSL or use a global RSL and actually localize that and apply that. So now if we have the RSLs there, then for each system, we can assign the RSLs to the various Flocken equipment for that equipment group. And if that's done, we could say, hey, we then do it for the next group of equipment, the next systems, and next planned unit. And then we have an end state where all these RSLs are assigned next to the RCM studies that were done. And then we may go to a step called optimization to say, hey, are now the tasks that we get out of this sufficiently aligned? Here you see an example on this motor where you can do the assignment of the maintenance library. And here you see that the tool allows you to make a selection of which failure modes are available from a reliability strategy library. Here all are selected, and here you see from that selection of that RSL that is copied in, and you may realize, hey, this can go pretty quickly. Yeah. On dashboards, I already showed you this dashboard, but I like to extend on it. In the tool, we can create multiple dashboards, and it would be good for you to think of, okay, what are the quality checks I want to do, and can I create a dashboard linked to my quality checks, so that I, in a systematic way, can assess what kind of work was done and how good that is. Yeah. Part of the IMS instance is an handbook, and in the handbook, you see here, there's quite some information available on the dashboards, and there are even for the RCM quality dashboards some details given, so you can use that to create your own dashboard, to modify your own dashboard, and to tune that to your own needs and interests. Yeah. In the filters of the tool, you can see here that the data in the grid is already analyzed, and you see here the statistical information present. So in this case, you see there are 77 high criticalities. Yeah. So in your quality check, you may go through this step by step and say, hey, I want to check all the high criticalities, or I want to check all the medium, high, and high residual risks, or I want to check all the analysis where the economic justification is low. Yeah, or I want to check all the incomplete analysis. Why are they incomplete? Should we do something there? So the quality checks can start off from very basic, but can be put together further in a more total picture for the total quality. After the tasks are created, we typically end up with the question how to execute these tasks. And one of the first things we need to answer is there an interface between the sub instance and IMS? Is there sub or is it Maximo or Pacer or another tool? And is that interface that's applicable there? What are the elements there? Are the elements just reading from sub, or is IMS allowed also to write to sub? And of course you realize that there are also authorization levels involved, what you are allowed to do, etc. Next step is, do we want to hold the task as a master in IMS and send over the task for execution, or do we want to master the task execution in SAP? So if you master task execution in SAP, you may create their PM plans and items with task lists, and then automatically work orders are generated to execute the work. So then the engine to create the work orders resides in SAP, and typically one needs then, say, what we sometimes call a preventive planner to manage that. But you can also hold and master the task on the IM side and actually send it over to SAP. So here I have an example where there's a schedule here, and this is a preventive schedule on this heat exchanger E2104. In this case, we have sent it over to do a commissioning on this heat exchanger, and this can be sent out to SAP, can be picked up as a notification, the work can be done, history can be written, and the history can be obtained back on the IM side. So then you can completely own this from the IM side. Here you see that not only the objects can be sent out to SAP, but also objects that are created in SAP can be sent back. So here you see an overview of corrective work orders for this tank 1125. And you see some of the notifications there that are used on the IM side. So now you get a picture of both. Hey, how does my maintenance look like? How do I do my reliability analysis? And am I capable of influencing with my RCM analysis the maintenance on the sub side and the maintenance in the execution, and improve the reliability of my plant unit? Another object we have is when we send over the schedules, we can say, hey, we want to have a certain set of history that we want to capture. We call it an equipment condition history, ECH. And in there we can say, hey, we want to have a number of standard elements that we want to have checked and verified. And these standard elements, we can put it in a form, sometimes called dynamic form. And here I have an example of a dynamic form for a reciprocating compressor. I'm not saying this is perfect, but it is detailed, and it may trigger off your thinking to say, hey, we also have some complex machines and we want to like to do some of that overall work in a more standardized way. So you can send this over for execution. We also have an application called IMS for fields using tablets. And in the fields, you can fill in the data in the tablet, pick up this, send it back to IMS. And then in IMS, you can actually analyze the data and compare it to the data you have captured before. But in that logic, you can also have some other types of forms, and here we have a form for an investigation. You may say, hey, we had a bit of an incident, something happened that we totally did not expect. We want this to be investigated in a structured way. And you can say, hey, here we have some standard steps in an investigation. But as I showed you on this heat exchanger where we do commissioning, you can also say, hey, before we put equipment into operation, we want to have a decent commissioning, and we have here a guided steps for commissioning. Put this in the form, collect your feedback, and bring this back to IMS. All right.
Thank you, Harry. We need to quickly wrap up before the webinar stops. You really did a great job in putting everything into this limited time that you had. It was really a comprehensive overview of RCM, I would say, really covering the essence. So thank you again. We have some I think, quite a bit of questions that we haven't managed to answer yet, but we promise that we will put everything in a document and share it with all the viewers afterwards. So for all the viewers, thank you really very much for watching, and hope to see you next time. We are planning a next webinar. We still need to decide on the topic, but it will be in February. Thank you.